There's water on the knee. Observation. It's a whole bucket of tea. Observation. A Charlie horse is true.
I figured this ad was fitting for this particular section because we're dealing with operations of radical expressions. This ad from 1995. I was 10 years old. I know, it was pretty impressive. Hope you liked it. That was in standard definition, by the way. We didn't have high definition back then, so you can see all the fuzziness and the graininess of all the video. Hello, it is I, Mr. Wharton, and I am back and bringing you 6.3 operations with radical expressions. If you notice, it does say operations, so the last couple ones were simplifying and then adding, or then multiplying and dividing. This particular one is going to be adding, subtracting, and then we're going to get into the multiplying and dividing aspect as well. So this is going to be kind of a long video because there's a lot of stuff that goes along with it. So I'm sorry in advance for that, the length of the video, but hopefully by the time you finish it, you feel very confident and can kind of get that practice going and take the power assignment here rather shortly. So let's get down to the nitty gritty because we got to get going here. So addition and subtraction of radicals. What we're doing is we're going to take our radicals, and there's a couple things we need to know. One is they have to have the same root, have to have the same, and we'll say index here, we'll say index and number inside in order to combine by adding or subtracting. Okay, so in number one here, if you look, the index is both 2 in both of them, and then my root, the number inside, they're 5 and 5. They're both the same. So what happens when I have the same index and then the same number inside is I look at the coefficients and I just combine those. Okay, so 3 minus 2 is 1, radical 5. We can think of these as variables. Okay, if it was 3x minus 2x, I get 1x. Okay, and this doesn't change. It's still just whatever that is. Same thing here. These do not change. It's just the numbers out front. So it's the coefficients change, right? Coefficients change, and that's it. Okay, coefficients change, not the number inside. Now, what happens if I don't have the same number inside, but my roots are still, my indexes are still the same? Well, this 20, I got to break it up. Remember, this is 2, 2, and 5, and this one here is 3, 3, and 5. So that 2 pops, that 2 crosses, so that becomes negative 6 root 5. And then this one here, the 3 pops, this 3 cancels, minus 3 root 5. Now, guess what? I have the same 5s, and my indexes are still the same. So now this becomes a negative 9 root 5. All right, there you go. So there's number 2. Number 3, well, these don't look the same, but remember I said odd root. Okay, odd root, odd index there, negative inside, the negative automatically pops. So that's negative 2, third root of 3, minus 3, third root of 3. Now they're both the same, so that becomes a negative 5, third root of, 3 of 3. There we go. Number 4, we're going to have some fun here. 162 is 3, 3, 3, 3, and a 2. And then 32 is a 2, a 2, a 2, a 2, and a 2. We got 5 2s there. We got 4 3s here, and so on. So this 4 tells me I need 4, right? So one of the 3s pop, the other 3 3s get crossed. One of the 2s pop, the other 3 2s get crossed off. So this becomes negative 9 times the 4th root of 2 plus this 2 that popped becomes, with that 2 becomes a 4 times the 4th root of 2. Now again, my numbers inside are the same. Therefore, I can now add them together. Negative 9 plus 4 is negative 5 times the 4th root of 2. Okay, what I want you guys to do is in numbers 5 and 6, okay, numbers 5 and 6, I know we haven't done 3 of them, but it's the same processes. I want you to try them. 5 and 6, go ahead and pause video now. So number 5 here, remember 20, we've got to break it down. All right, so this is 2, 2, and 5, so the 2 pops, the other one gets crossed, so that's 4 root 5. Minus root 5, can't do anything with that one. And then this 24 is 2, 2, 2, and 3. So a 2 pops, a 2 gets crossed off, and then this stays inside. So that's minus a 4 root 6. Now, these are the only ones that that can be combined. I know I kind of drew a line there, but the first one and second one here are the only ones that can be combined. So that's a 3 root 5 minus a 4 root 6. Now, some of you might be thinking, well, what if I wrote it this way? Would I be incorrect, or would I be still correct? They're both correct, okay? The order doesn't matter in which they're written. You just have to make sure that because this is a negative 4, that when you write it, the negative goes with it. That's the only thing you have to really remember. Number 6, 32 can be written as 2, 2, 2, 2, 2, 5 of them. So I have 3, so I got to pull 1 out, cross, cross. Negative 108, remember the negative can go out, right, because it's an odd index. So 108 is 2, 2, 3, 3, 3. So I need 3 of something, so the 3 can pop and the other 2 get crossed off. And then 54, what is that? Well, that is 2, 3, 3, 3. So one of the 3's goes, the other 2 get crossed off. So now let's rewrite it. I brought a 2 out, so that becomes a 6. And then the third root of what's left inside, what did I leave? I left 2 2's, which makes a 4. What happened here? I brought a 3 out, so that becomes a negative 6. But I brought a negative out, right? So it becomes actually a positive 6. Oh, man. Don't forget that negative. All right. And then what happened? I left 2 2's inside. Haha, 2 2's. There we go. 4's left in there. And then this one here, I brought out a 3, which makes it just a 3. And then what I leave inside, I left just a lone 2. He's a lone member right there, a lone member of the band. 6 plus 6 is 12, third root of 4, minus 3, third root of 2. Again, order doesn't matter, but that is your simplified answer. Okay, if you want to get really awesome, let's get into some really hard, not really hard ones, but 4 numbers, okay? So 2 root 12, root 2, 3 root 54, and 3 root 27. Let's break them down. 12 is what? 2, 2, and 3. This is by itself. That can't change. 54 is 2, 3, 3, 3. And then 27 is 3, 3, 3. If you can't do those that quick, again, that's okay. Do the prime factorization of factor trees. So 27, right, would be 3 and 9, and then 3 and 3 as well. So that's what I'm doing in my head that fast, okay? So what happens? I bring a 2 out because they're both squares, cross. I'm bringing a 3 out, cross the other 3 out, bringing a 3 out, cross it off. Here we go. 2 times 2 is 4 root 3 minus root 2 minus, I brought, what did I bring? I brought a 3 out, which brings a 9. Root what? 2 times 3 is 6. And then this one here, I brought a 3 out, which makes a positive 9. Root what's left of 3. Can I combine anything? Yeah, right there, right there. You get 13 root 3 minus root 2 minus 9 root 6. There you go. Right there, right there. Okay, doesn't matter. Again, doesn't matter the order. Then you have everything else you need. Okay, that's all you need. I want you guys to go ahead and try to do number 8. Okay, hit pause now. Okay, number 8, let's come back to it. I know 486, technically you can combine the 486 here and here already, and you can get 5 of them. But because 486 is a really large number, I can actually take things out first. So let's do that. So 486 is actually 2 times 3. Times 3 times 3 times 3 times 3. I believe that's what I get. So 3, 9, 27, 81, 243, 486. Okay, we're good there. Perfect. So what happens? I need 4, right? So I bring out a 3. Then I cross, cross, cross. So that means I have a 6 out front. I have the 4th root of what's left, 2 and a 3, right? This I didn't touch and this I didn't touch, which makes a 6. Minus a 3, 4th root of 6. Can't change that 6, right? Minus 2, 4th root of 5. Plus, well, if I know that this was 2, 3, 3, 3, 3, and 3, I brought the 3 out, right? Makes it a 9. Cross, cross, cross. So I have a 6 left. We know we're going to have a 6 left because that's what I have over here. So let's see what I got. I got 6 minus 3 is 3, plus 9 is 12 times the 4th root of 6, minus 2 times the 4th root of 5. Okay, that's how you do those problems. I want you guys to do the next 2 and then hit play. Number 9 here, let's go through this one here. I got 4th roots and 5th roots, and I got 3rd roots as well. So just because the number inside might be the same, we have to check our roots, our indexes, make sure they're exactly the same. So right now it only looks like I could add this one and this one if the number inside is the same. Okay, those would be the only two I could add. So let's see what I come up with here. 160, what is 160? That's a 2, that's a 2, that's a 2, 2, 2, and a 5. Okay, so there's 5 2s times a 5 in there. What is 324? That is, oh man, that is a 2, a 2, a 3, a 3, a 3, and a 3. I believe that works out. This one here is a 5. Remember, the negative pops out because it's an odd root. So 96 is, oh man, that's a 2, 2, 2, 2, 2, 3. And then this 32 over here is, holy cow, 2, 2, 2, 2, 2. Dang, that's a lot of 2s and 3s, and holy cow. So I need 5 of something. I got 5 2s, so 1 pops, cross, 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 cross. I left with a 5, so that becomes a -6 root 5. I need 4 of something here, so I got 3s, so that 3 pops out front. Cross, cross, cross. I'm left with a -3 root 4, which is, oh, I'm sorry, I've got the indexes there, 5 and then a 4. Whew, man. So this becomes what? Becomes a 4, and then times the 5th root of what? Of 3. And this one here is, oh, it's exactly, oh, it's not. Cross, cross, so that becomes a -2 times the 3rd root of 4. That's 2 times 2 is 4. So can I add any of these together? The only ones that I could add together were potentially this one here and this one here, but they're not the same numbers inside. So you can't add them anything together. So that is your answer there. Okay, that sucks, but it is what it is. So you have 4 terms in this particular instance here. Number 10, let's break them down. 32 is 2, 2, 2, 2, 2. So I can pull a 2 out, cross, cross, cross. So that becomes a -6 times the 4th root of 2. This is plus 2 times the 3rd root of 2. Can't do anything with that. 135 is 15 times 9, which is a 3, a 3, a 3, and a 5. So I can pull out a 3, cross, cross. That becomes a 6 times the 3rd root of 5, plus, and then 54 is 6 times 9, right? So it's a 2, a 3, a 3, and a 3. So I can pull a 3 out, I can cross and cross. So it becomes a 9, and then the 3rd root of 2. Dang, that's a lot of work. All right, what can I add? Can I add anything? Yeah, I can. Actually, I can add this one and this one because they're the same roots and the same numbers inside. So 2 plus 9 is 11. 3rd root of 2 minus 6. 4th root of 2 plus 6 times the 3rd root of 5. You might see me sometimes like put like a little hook on my numbers here. I haven't been doing it lately, but I tried to myself. What I do that for is that shows me as the person writing it and the person reading it that that's the last number inside. Sometimes we will write our answer this way, and I don't want us to because this is not right. So we'll leave this line like pretty long, and then we'll just keep writing. 4th root of 2 plus the 6th root, that like that. Okay, you see kind of like some of that stuff is underneath the root, and that's not what you mean. You only want that 2 to be in it and only that 2, you know what I mean? So please make sure that make this line as long as you need. Don't make it extra, extra, extra long, okay? All right, what I want you guys to do is take the time to sum up how to add and subtract radicals, okay? That's like your little notes for the first page. Sum up how to do it. Hit pause now, and then I'll discuss it without writing it down so you can make sure you have what you need. Okay, go ahead and hit pause now, please. Okay, sum up how to add and subtract radicals. Remember what you need is you need the same index. Actually, I wasn't going to write it, but I guess I can. Same index, same what we call a radicand. Remember from the first 6.1 section, radicand was the number inside. And what else do I need? I need what changes? Well, when I do these, the coefficient changes. coefficient, I spelled it wrong again, like I did up top. Coefficient changes, but the number inside does not, just like a variable, right? And I can even say, okay, 2x plus 6x is 8x, right? 2 xylophones plus 6 xylophones now makes a grand total of 8 xylophones. I don't know who is starting a band, but they got a lot of xylophones, I guess. Ding, ding, ding. I love playing with those things as a kid, man. Okay, so let's go on to the next page, which is going to get a little harder, so bear with me here. Okay, the good thing is that we somewhat did some of this before in 6.2. I didn't explicitly go over it, but I did mention it. So hopefully we have some understanding of this. I did talk about multiplying radicals, and I did say something about this. I said, when multiplying radicals, you do inside with inside and outside with outside. Now, the couple things you have to mention as well, make sure the indexes are the same, but they're going to be the same. They have to be the same. Otherwise, you know, that'd be stupid. I wouldn't give you problems that look like that, okay? So let's multiply inside with inside. So in this case, this is all together. That's just one monomial, right? That's a monomial times that 3 times that root 6. So I'm distributing inside with inside, outside with outside. If I do not have an inside, then my inside here is going to stay the same. So that's root 6. 3 times 3 is 9, so negative 9 there. Now, this one here, when I multiply negative 3 root 6 times the root 6, well, my root 6 and root 6 actually becomes a root 36, right? And then this negative 3 is going to stay there. But root 36 actually equals 6. So that has to be multiplied by the negative 3, which makes it a negative 18. So I get negative 9 root 6 minus 18. And again, you can write it in any order you want. That's your final answer there. Let's multiply here. Okay, here and here. So that becomes negative 2 root 50 minus 4 root 5. But 50 is 2 times 5 times 5. The 5 pops, the other 5 crosses out. So that becomes negative 10 root 2 minus 4 root 5. And I cannot combine those together. Okay, I cannot do those together. Number 13. Again, inside, inside, outside is outside. So here we go. Boom, boom. That's what? Root 18x, okay, plus root 6x. Now, 18 is 2 times 3 times 3. So a 3 pops and a 3 gets crossed off. So that's 3 root 2x plus root 6x. And that's your answer for that one. These aren't that bad. Hopefully not. This one here, root 25x when I multiply plus 4x to the third root 5, because inside with inside, outside with outside. This doesn't, there's no inside here, so it stays there by itself, and there's no outside here. Really there is, but it's a 1, so that's why it's just 4x to the third power. But 25 is 5 and 5, pop, cross, so the 5 root x plus 4x to the third root 5. There we go there. Woo, those are actually a little easier. And now it's going to get a little harder. Now we got to keep track of our stuff. Okay, let me scroll down a little bit and get there. Alrighty then. Alrighty then. I was like Jim Carrey in some like Ace Ventura, Pet Detective, or When Nature Calls, or whatever.
Alrighty then.
All right, 15. If you look at it, now I have binomials here and here. So what does that mean? I have binomial times a binomial. That means we need to do a box. Or for some of you, you FOIL, and that's okay. I don't care how you want to do it. You just need to make sure you get the right answer. I'm going to show you a box. It's very visual. Some of you are very visual learners. So no excuses and say that I never do something for you guys, all right? Here we go. I'm going to put this binomial. I can put it on top or on the bottom. It doesn't matter. I'm going to put it up on top. 3 root 5, root 2, and then negative 5 root 5. Now, I'm going to kind of go through some tricks and everything on how to show you, I guess, easy ways to do it in your head instead of writing everything out. But if you need to write everything out, you're more than welcome to do so. You just might not have enough room there, especially if you write rather large. Root 2 times root 2. Well, these are both square roots. When I have a square root of the same number times the same number, I just get the number that's inside. Why? Because technically this is a root 4, which makes a 2 anyway, right? This one here is a 3 root 10, right? 5 times 2 is 10. This one here is a negative 5 root 10, right? 2 times 5 there. And then this one here is technically, so let's think about this. Negative 5 times 3 is negative 15, but I have a root 5 and a root 5. Well, from up here, that makes it a 5. So really, this should just be a negative 75. What does that mean? How does that make sense, right? 3 times negative 5 is negative 15. Root 5 times 5 is 25. Well, what is root 25? 5. 5 times negative 15 is negative 75. Oh my gosh, you just learned something. Now let's combine terms. 2 minus 75 is negative 73. Negative 5 root 10. 3 root 10 is a negative 2 root 10. There you go. That's it. It's not really that hard. You just got to make sure you're keeping track of your actual roots and stuff like that. Here we go here. Number 16. 16 candles. Negative 3 minus 4. 2 root 3 minus 2. Here we go. This is going to be a 6. Remember, root 3 times root 3 is 3 times 2 is 6. Okay, negative 8 root 3. This is negative 2 root 3, and this is going to be your 8. 6 plus 8 is 14. Negative 2 root 3, negative 8 root 3 is negative 10 root 3. Sorry about that. Here we go. This one here, boom, goes the dynamite. 5. Root 3. Now we have a variable, but that doesn't matter. It's the same process. Negative 2 root 5k, and then a negative root 3. So let's multiply. Now this one here, I have a 25k that's going to be inside my root, but the k is going to stay there because there's only one of them, but the 5 is going to pop out, which makes it a negative 10. Okay, which makes it a negative 10. So please make sure you understand this. I'm going to start skipping some steps here. I'll mention it in the videos, but I'm going to start skipping some steps. Okay, just for that purpose. This one here is going to be a negative 2 root. 5 times 3 is 15, and then a k. I can't do anything with anything else, so that's going to be there. This one's going to be negative root 15, and then this one's going to be a negative 3, because 3 and 3 make 9, which makes square root of 9 is 3. Now let's combine terms if I can. This is a k and this is a 15k. Can't combine them. They're different. And this is a 15. Can't combine them. They're different. So my answer is just what's in these boxes. Negative 10 root k minus 2 root 15k minus root 15 minus 3. So all of that jumbled mess is your answer. Okay? I'm going to erase some of that as well so I can do number 18 there, kind of in that box. So I'm going to erase it, so make sure you have it. Okay, number 18, well, again, make my box. 3 root 5r, 5, 2 root 5r, and a negative 1. Sounds like a little robot. 2 times 3 is 6, but now 5r and 5r, those are exactly the same. So those 5r's both pop out. Boom, one of them, right? One of them pops. So 6 times 5 is 30r. I don't know how you can't get excited by doing these problems. I'm almost out of breath by talking to you right now. This one here is going to be just times a negative 1, so it's just a negative 3 root 5r. And then this one here is going to be a negative 5, right? So now, can I combine those? No, I can't, because one's an r, one's not. So it's just 30r minus 5. And then can I combine the 5r here and that 5r? Yeah, I can, because they're the same thing. So negative 3 and 10 make a positive 7 root 5r. We should get like excited up in here. All right, that's multiplication in a nutshell. That wasn't that bad. I don't think it was that bad. Now comes the hard stuff. All right, dividing radicals. This is really where it's going to get really hard. This is where you're going to earn your money. Okay, you're going to earn your grade. You need to know a couple different things: conjugates and rationalization, or rationalizing. Okay, and we've talked a little bit about conjugation before. When we had, this was actually in 4.3, when I wrote something like 2 plus 3i, and then you had to write the conjugate or its other root, and it was 2 minus 3i. That's what a conjugate is. Basically, a conjugate is the opposite, I'm going to abbreviate a little bit, the opposite binomial that will cause you to get rid of roots or i's. And I'm not going to deal with i's, but I'm going to put the whole definition down there. But it causes you to get rid of roots. Okay, so for instance, if it was 2 plus root 3, then the conjugate would be 2 minus root 3. All you're doing is changing these signs here. Everything else stays the same. You're only changing the plus to a minus or the minus to a plus. Okay, and we're going to do through a whole bunch of those conjugations down at the bottom. Rationalizing, and I'll show you some shortcuts down there too. Rationalizing. This is the process of which no roots or i's, I know we're not dealing with i's, but I just want to again go through the whole thing. Process of which no roots or i's are left in your denominator. Now you might be asking, like, why? Like, what is the purpose of this? Well, we rationalize because it just looks bad. If I have a root left in my denominator, like say for instance, oh, that's my answer, and I'm gonna leave it like that. I have roots in my denominator, and that, as a math teacher and a math person, a learned individual in the mathematical sciences, it just causes me to like cringe. Like I want to go like bury myself in the corner and like crawl up and, you know, just start to cry. I hate, and it's not very good. It's not mathematically proper for you to leave i's or roots or, you know, other things down the road in your denominator. It just doesn't look very good. So we want to kind of make it clean. Like, you know, we want to butter it up and take it out to dinner. And how do I do that? Well, I'm going to rationalize. I'm going to conjugate the denominator and then do all my stuff. Okay, so let's kind of get started. This is going to be the hardest stuff. So please make sure you're paying attention, taking notes, asking questions, so we can be successful. Okay, that's our ultimate goal here. So let's kind of get started here. So the beauty of this thing here is, I believe, if I remember correctly, that all of the roots that are going to be in the denominator are always going to be square roots, because we can't conjugate something that's not a square root. That just makes it really, really crazy, and we don't want to do that. So let's make sure we're only dealing with square roots, okay, which we are. So what I want to do is I want to take this fraction and I want to multiply it by its conjugate, top over bottom. So my denominator is 2 plus 5 root 3. And according to this little graphic here, okay, all I do is change the plus to a minus or the minus to a plus. So this minus is going to change to a plus. That's the only difference, okay? That's the conjugate, because now when I multiply this binomial here and this binomial here, I will get the middle term. Usually it's like something here squared. This is usually just an x and this is some number. When I do this conjugation, this middle term cancels and I'm left with just this and this. So then I can just combine those together and I should not get any roots left. If you end up with roots in your denominator, once you multiply by the conjugate, either you multiplied by the wrong conjugate or you just didn't multiply correctly. Okay, and we have to make sure we multiply correctly and by the right conjugate every single time. All right, now I'm going to show you some tricks, because some of you are going to do a box, okay, and you're going to do, 2 minus 5 root 3, and you're going to do a 2 plus 5 root 3. And you can do a box. You're more than welcome to do so. When you do a box with conjugates, with binomials, okay, right, these are conjugates, the only boxes that are going to matter are this diagonal here. This number and this number aren't, you don't even have to fill them in, because if you were to fill them in, they would cancel with each other. So this would cross off and this would cross off because they would add to 0. So the only ones that matter are this diagonal. So if I think about this, 2 times 2 is 4, right? And then negative 5 times 5 is negative 25. And then the trick was 3 times 3 is really 3, right? Because it's root 3 and root 3. So that's really a negative 75. So my denominator is going to be negative 71. 4 minus 75. Okay, negative 71. So that's your little trick, right? When you do a conjugation of your denominators, this box and this box you do not have to fill in. For those of you that are foiling, please pay attention now. If you are foiling this, okay, and you do first, outer, inner, last, for those of you that do this, the only ones that matter are the first and the last, okay? If you're not first, you're last, like Ricky Bobby would say, okay? The middle terms here don't matter. That's the two boxes that I showed you that crossed off, okay? First and last, those are the only ones that matter, and you would still get negative 71. Please make sure you do that on your power assignments, tests, review, practice, all of your stuff. This will save you a boatload of time, okay? A boatload of time. Instead of doing other stuff that's going to cancel and you know will cancel, all right, make sure you're doing kind of the shortcut here. Okay, we said our denominator was negative 71. Now we're going to distribute just like I did up atop in the multiplication. 3 times 2 is 6. 3 times 5 is 15 root 3. Remember I said that inside with insides, outside with outsides. Now, some of you might leave your answer this way, and I'm going to tell you right now that will be marked wrong. The reason why it's not correct is because I never want denominators that have a negative symbol down there. Okay, so what happens, in order to make this a positive number, so that's what I want, so your answer is going to contain a positive 71, every sign up top changes to its opposite. So this is going to make this a negative, and this negative is going to make that a negative. So minus 15 root 3. That is your answer. If you put a negative number in your denominator, it is wrong. It's just like having a square root down there as well. I don't want it. Okay, please don't put it down there. All right, so that's your kind of forewarning here. Number 20, let's multiply by its conjugate. So it's 3 root 2 minus 5, 3 root 2 minus 5. Why am I multiplying? Well, technically, these are both the same numerators and denominators, so technically this makes a 1, right? So if I multiply something by 1, it doesn't change the value of the problem. All that it does is just change the way it looks. That's what I'm doing. I'm changing the way it looks. So here we go. 5 times 3 is 15 root 2 minus 25 for the top. The bottom, I'm going to do a shortcut. Remember, you can do F or L, or the F and the L in FOIL, or you can do the boxes, the top left-hand corner and the bottom right-hand corner. Those would be added together. So here's what I would get. I get 9 times 2 is 18 minus 25, which is a negative 7, which that negative 7 can't be negative, right? So it changes and it changes. So my answer is negative 15 root 2 plus 25 over a positive 7. So there is your answer for that one. Here we go to this one. I know this has got a variable, but it doesn't matter. It's the same thing. I'm going to multiply by its conjugate. Okay, its conjugate, here we go. We got 5 minus 3 root 5p squared. 5 minus 3 root 5p squared. Multiply. 5 times 5 is 25, right? Minus 5 times 3 is what? 15. But I have a p squared with a square root, so technically I can pull a p out, right? Because 2 goes into 2 once and there's nothing left inside. So that's what I get. That's my numerator until we get to the denominator, right? It could change, but that's my numerator so far. Now let's multiply. 5 times 5 is 25. 3 times 3 is 9 times one of the 5s that's going to pop out, which is 45, so minus 45. And then I get what? I get a p squared, right? P squared should pop out as well. Now, can I combine these two? I don't have a p squared and I don't have a p over here. Well, can I combine? No, you can't. Okay, you cannot combine these two. So this is what I have so far. And then if I look at the 15 to 25 to 25 and the 45, can I divide all of those numbers by something? Well, sure, I can divide them all by 5. So divide by 5, I get 5. Divide by 5, I get 5. Divide by 5, I get 9. Divide by 5, I get 3. So let's rewrite it. I get 5 minus 3p root 5 over 5 minus 9p squared. That is your final answer for number 21. All right, let's move on. We got a couple more there to do, and then you'll have some practice time yourself. All right, number 22 here. Let's multiply by the conjugate, right? So it's what? Negative 4 minus root 2p to the third. Again, the only thing I changed is this middle sign here. Everything else stays the same. So then up top, I get negative 4 minus root 2p to the third. So let's multiply the top together. I get 3 times -4, which is a -12. 3 times the -1, which is a -3. But I got p to the third on the inside, so one of them can pop out. And then what's left on the inside? Well, it's just a 2p. Okay, remember 2 goes into 3 once, and the 1's left inside. Got to know that. We can't just forget about our rules from 6.1 and so on. Now let's multiply the bottoms. -4 times -4 is a positive 16. Then I get what? I get root 2p to the third and root 2p to the third, so that's a minus 2p to the third. Again, if you need to do your FOIL, F and L. Okay, F and L. Now, I'll show you on this one kind of how it works. I'll show you the box and I'll show you the FOIL just to make sure you do it, because then down here we're going to have some more variables as well, and I'm going to kind of skip some of the steps. So if I do the box, I get -4 and then root 2p to the third. On this one here, I get -4 and then negative root 2p to the third. So this makes a 16. Remember, I said these boxes don't matter, right? I don't need to write anything in them because they will cancel, which they will, all right? And then this one here would be negative. Root 2 and root 2 makes a 2, right? And then p to the third and p to the third. That means I have 6 p's, but I have a square root. So how many times does 2 go into 6? Well, again, the 3. So 16 minus 2p to the third. That's what you get. Can I reduce? Everything is divisible by 2? Nope, because that's not. So that's your answer there. Oh, and then if you did FOIL, this would be your F term, and this would be your L term. Okay, F and L, F and L. If you ain't first, you're last. Ricky Bobby. All right, 23. Let's go there. 23, conjugation is what? It's 3 root 3 minus root 2. 3 root 3 minus root 2. Alrighty, here we go. Let's do the top first. The top is a binomial and a binomial. I can't skip steps up there because it's not the conjugate. So I actually have to do my box. So this is -4, 4 root 3. Sorry, 4 root 3. This is 3 root 3 and a negative root 2. Multiply, that's 12 root 3. That's 12 root 9, which is really a 36. This is a 4 root 2. 2, 2, 2, there we go. And then this is a -4 root 6. There we go. And then this combines to what? It combines to a 12 root 3 plus the 36 plus the 4 root 2 minus the 4 root 6. I can't combine any of those, so that's why it stays that way. Divided by what? 3 times 3 is 9, times 3 is 27. And then root 2 and root 2 makes a -2, so over 25. Can I reduce? 12, 36, 4, 4, and 25. All of those cannot be divided by the same thing, so that is your answer there. Let's go on to 24. Multiply by the conjugate. Conjugate is root 5 minus root 3, root 5 minus root 3. Top, I got to put into a box. Those are binomials. I know it's kind of crazy. Some of these are really long, but it is what it is, all right? It is what it is. I don't know where that saying came from because everything is what it is, so I don't know. We just wanted to be fancy, I guess. So that's just 5 root 5, right? This is now 4 root 10. This is -5 root 3, and then this becomes a -4 root 6. Can I combine anything in those boxes? No, I can't, right? So it's just 5 root 5 plus 4 root 10 minus 5 root 3 minus 4 root 6 over what? Again, FOIL, F and the L, because it's the conjugate. First would be root 5 and root 5, which would be your 5, right? And then root 3 and root 3 makes a 3, so -3. So your denominator is actually a 2. Can I reduce 5 and 2, 4 and 2, 5 and 2, 4 and 2? I can't divide them all by 2. So this is it. I am done right there. Okay, 2 more to go. These are a little harder, so these are going to take a little extra time, but that's okay. These are going to take a lot of room. That's why I gave you a lot of room for writing. Man, I'm like considerate up in here. Okay, conjugate, which is 3r minus root 5r to the 4. Holy cow, this is going to be a great one. I'm already loving this one already. I'm already like, why did I put this on here? Let's do the top in a box. or you can FOIL it yourself. I don't care. I'm just going to do a box because I like doing boxes. I just don't like putting all my stuff in a box and moving to the left. -2 root 3r to the third, 3r minus root, holy cow, 5r to the 4. Okay, this is what, a 9r. This becomes a -6r, but technically I have 1r that can pop out of here, right? So it's r squared, root 3, and then I should have 1r that's left inside because I can only pull one out, cross one out, and then one's left in. This one here would be -3 root 5r to the 4. Okay. Well, technically, I did that one wrong too. R to the 4 could technically be pulled out. So I got to rewrite that. So it's really -3r squared, right? I can pull out 2 r's, root 5, and there's no r's left. So that actually is wrong. And then this one here is a, holy cow, +2. And then I have 4 r's and 3 r's. So that makes 7 r's, which if I'm dividing those by 2, I can get 3 of them to pop. And then what am I left with on the inside? I'm left with a 15 and a single one in there. Okay, now let's, I guess, combine if I can combine. It doesn't look like I can, so let's just kind of write them. I get 9r minus 6r squared root 3r minus 3r squared root 5 plus 2r to the third root 15r. All of that terrible numerator is going to be over 3r times 3r. This is your F term in your FOIL, or your first box in the box. First box in the box. That's 9r squared. Root 5r to the 4 and 5r to the 4 is a -5r to the 4. Okay, and I can't combine those two, so that is my answer and my numerator, or my denominator, 9r squared minus 5r to the 4. Oh man, okay, can't reduce 9, 6, 3, and 2, can't be reduced by 9 or 5. Then since all of them have an r, I can divide by r, so I have to do that. Alrighty then, let's go to number 26. Conjugation, conjugates, 3n plus 2 root 5n squared, 3n plus 2 root 5n squared. Okay, let's do the top in a box. Let's do the top in a box. 4n minus 3 root 5n squared, 3n, 2, holy cow, 2 root 5n squared. I'm just talking a lot. I'm sorry. I know I'm probably boring a lot of you guys to tears, but some of these problems take a while. That's 12n squared. This is going to be a -9n root. Oh, no, it's wrong. Sorry. So this is going to be a -9n, but I can pull one n out from the inside, right? So it's really a 9n squared root 5. And then this one here is going to be an 8n, but I can pull another n out, so it's 8n squared root 5. Oh, that makes it nice. I can actually combine those things. That's pretty nice. And then, then your after one over here is going to be a -6. 2 times -3 is -6, but then the times it by 5, right? So it's really a -30, and then n squared is what that is. So that's actually a really nice one. I can combine those two together. That gives me a -18n squared, and then I can combine those two together, which gives me a -1n squared root 5. Over what? The F, 3n times 3n is 9n squared. -2 times 2 is a -4, but then all of that times a 5n squared. Okay, a 5n squared there. So that's a 9n squared minus 20n squared, which is -11n squared. -11n squared, but then I don't like negatives in my denominator, so this changes to a positive, and this changes to a positive. So I get 18n squared plus n squared root 5 over 11n squared. Since all three terms can be divided by n squared, you have to divide them by n squared. So it'll be 18 plus root 5 over 11 would be your final answer. If you notice this you try section, it actually is probably some of the hardest problems that we've done from the multiplication and dividing sections. So yes, they're kind of long, but again, you should hopefully have a good understanding. It's not really hard. I don't think the processes are hard. I think it's just time consuming. I think that's where some of us are getting kind of mad about this, right? -5 and -2 makes a +10. Root 15 and root 10 makes a negative, or I'm sorry, makes a root 150. Minus, that makes a 15 root 15. That's pretty cool. And then this 15 is actually what? It's actually 2 times 3 times 5 times 5. So that 5 technically pops out. So that becomes a 50. That 5 gets crossed out. Root 6 minus 15 root 15. Sorry. And that's your answer there. This one here, number 28. They're not conjugates, so you either need to do a box or FOIL or something, however you need to do it. I don't know if you can make up some math to get the right answer. I guess that's fine as well. This is negative root 3, and then this is a -4 root 5. So here we go. This is -4 root 6. This is going to be a -5 root 15k. This is -16 root 10. And -4 and 5 makes a -20. But since there's 2 5s in there, technically can pull one out, so that makes a -100. And then a root k. There's only one k, so I can't pull another one out. So let's rewrite this. I cannot combine any of that. So my answer is -4 root 6 minus 5 root 15k minus 16 root 10 minus 100 root k. Okay, so that is your answer right there. 29, I need to multiply by its conjugate, which is 4x plus times 5 root 5x squared. 4x plus 5 root 5x squared. Let's multiply the top. 5 times 4 is 20, but I have an x to the squared, or x to the 4th inside. So that becomes 2 when it pops out, which I already have an x, so it becomes x to the 3rd with the 2 inside, plus 5 times 5 is 25. And then I have 4 x's again, and then I have 2. So I can take 3 of them out. Root what? Root 10, right? 2 times 5 is 10. Over. Now, this is where the F in the first box and the last box and the L's and all that stuff. 4x times 4x is 16x squared. Minus 5 times 5 is 25 times another 5 that pops out, which is 125. X squared and x squared, I pull an x squared out. That makes this combinable, which is -109x squared, which, because this is a negative, this needs to turn to a positive, which makes that a negative, which makes that a negative. So my answer, -20 x to the 3rd root 2 minus 25 x to the 3rd root 10 over 109 x to the 2. I'm not done yet. I know it's a crazy problem. I'm not done yet. I thought I was, but then I looked at it and I'm not. I'm not done because I have x to the 3rd, and x squared, so I can divide them all by x squared. So x squares are gone. This becomes just a 1, and that becomes just a 1. So answer -20x root 2 minus 25x root 10 over 109. Okay, that's your answer there. All right, let me erase that and get to 30. Okay, number 30, again, conjugate of your denominator is -3x squared plus 2 root 3x squared. Oh, 3x to the 3rd. Sorry, I read that wrong. -3x squared plus 2 root 3x to the 3rd. Up top, let's do a box for that one, and I get 3 root x, I get a 4x, get -3x squared, and a 2 root 3x to the 3rd. So I'm going to do this real quick. If you need to pause and slow down, that's fine. I mean, you should have already done it, but if you need more time, that's fine. This would be -9x squared root x. This is going to be a -12x to the 3rd. This is a 6 and then a 6x squared root 3. And then this is going to be an 8x squared root 3x. Remember, I can pull an x out, right? Pull an x out from here, technically multiply, and that's how I get that. So my numerator is -9x squared root x minus 12x to the 3rd plus 6x squared root 3 plus 8x squared root 3x over what? Over negative 3x squared. Negative 3x squared is a 9x to the 4 minus 2 times 2 is 4 times 3 is 12 x to the third. And that's our answer there, I believe. No, I'm kidding. That's not it. I am going to erase some of this so I can kind of show you what your answer is going to look like. Now, the reason why your answer is not correct right here is because of the x's. All of these have an x squared, at least an x squared in them, so I can pull an x squared out of them because I'm dividing all of these by x squared. So this 4 technically becomes a 2. This becomes a 1. That just goes away. That goes away. This one here becomes a 1. And this one here goes away. Now let's look at everything else. 9, 12, 6, 8, 12, and 9. Can all of those numbers be divided by the same thing? No, it cannot. Either 2 or 3 or 4, it can't be divided by any of them because this is 8. Really, this 8 is the weird one here. Some of you might be like, well, I have x's on the inside of my roots. Those are separate. I can't do anything with these x's on the inside because those are really by themselves. They're like separate of everything else. So only the numbers on the outside can I start simplifying with. So now let's rewrite it here. I get negative 9 root x minus 12x root, oh, nothing actually. So minus 12x plus 6 root 3 plus 8 root 3x over 9 x squared minus 12x. Now you can do some other simplifying too. You can pull an x out of there and a 3, and you can do it. That I wouldn't worry about that because I can't simplify. My numbers come together 9, 9, 12, 6, 8, and 12. I can't simplify those, so then you're technically done. All right, so this is your answer. All right, you can write it again any order up top or the bottom, doesn't matter, but that is your answer. Okay, that concludes this video. I am very, very sorry it's taking so long. I tried to trim it as much as I could and edit it, and I really, really tried. I couldn't get it anything less than what it is right now. So again, I'm very, very sorry, but it's a lot of information. So this section might take you a couple days to do. Okay, and that is okay. All right, you have the time. You just have to kind of make up and make sure we have that time at the end. All right, if you have questions, please ask in class. Work on the practice. If you are getting it, then you don't have to do all of the practice. That's not a big deal. Make sure you're getting some of the harder ones and easier ones and so on. But if you have questions, please ask. If not, then you should be good to go. Remember, take notes, do work, and you'll be successful. Okay, Wharton signing out.